probability. There will be multiplication, addition rule, multiplication rule. So we'll look into that in calculating probability. And the last thing will be the Bayes theorem. We will look into what is the Bayes theorem, what is the formula for Bayes theorem. Yeah. Okay, now basic concept of probability. So in probability, an experiment is process that when we perform result in one and only one of many observations. So this is just a basic concept of probability. You can see the outcome. What is the outcome? Outcome is the observations of the experiment. That is what we call outcome. And a sample space is a collection of all outcomes for an experiment. Okay, you can see here. So you can see this is the experiments. This is the experiments. Yeah, and this is the outcome. You can see that when you toss a coin you only have head and tail, right? So the outcome can be either head and tail, right? And when you roll a dice, there are the 6 sides, right? So you can have 1, 2, 3 until 6. So the sample space is the collection of all outcomes. It can either be head, tail, 1, 2, 3, 4, 5, 6, 4 dice. Okay, and if you take a test, it's either fail or pass. So this is a sample space. Yeah, this is a basic thing that you need to know on the probability. Okay, and the event. What is an event? An event is a collection of one or more of the outcomes of experiments. And a simple event is an event that includes one and only one of the final outcomes. So kalau dia simple, if we call it a simple event, it only consists of one event. So this is what we call example of simple event. So this is event 1, second event, third event, and fourth event. Okay, we call it simple event when it consists only one final outcomes. Yeah. Compound event. Okay, kalau compound event, it consists of more than one outcome for an experiment. Macam contoh like this one, suppose we randomly select 2 persons from the members of a club. Observe that the person selected each time is a man or woman. Let A be the event that at most one man is selected. So you can see A consists of one man. It is selected one man, so it can be one man, woman, woman, man, and woman, woman. Okay, at most one is selected. So what we call A as an compound event. It consists more than one outcome. Macam tadi, the simple event, it consists of only one outcome. That's why we call it simple event. For compound event, we have more than one outcome for the experiment, then we call it compound event. So this is the things that you just need to know lah, all right? So in a group of Okay, this is just example for what is a simple event and compound event. So in a group of students, some are in favor of genetic engineering and others are against it. 2 students are selected at random from this group and asked whether they are in favor or against genetic engineering. List all the outcomes included in each of the following events and determine whether they are simple or compound events. So whether they are simple or compound events. Remember, simple event consists only one outcome, while compound events consist more than one outcome. Okay. So the event where both students are in favor of genetic engineering. So both students are in favor of genetic engineering. So we have only one outcomes, right? So we know that this is a simple event. As for number 2, at most one student is against genetic engineering. So at most is one student. So this one, and this one, right? The outcome. So how many outcomes? More than one. So this is compound event. Okay. Now number 3, exactly one student is in favor of genetic engineering. Exactly. So we take out the both lah. Favor, we take out because we only want exactly one student. So it's either one favor once again, against satu, and favor satu. And this is more than one outcome. So this is a compound event. Okay, simple event is one outcome. Compound event is more than one outcome. Okay, kalau simple satu, compound event more than satu. Okay. Now we go into calculating probability. Okay. There are a few things that you need to know before you able to calculate the probability. I think most of you have learned this probability, at least basic of probability before this in STPM, in prior university, in matriculations, right? So now, these are the things that you need to know. So probability is likelihood of occurrence of an event and is denoted by P. Okay, we denote it as P. The probability that an event A will occur denoted by PA. So this is how we write it in terms of itulah probability lah, probability of A. So we write it P bracket A, probability of A. When the probability is for impossible event, so means that the event is impossible to occur, the probability will be 0. Maksud dia impossible untuk jadi. Impossible for that things to happen. Okay, is 0. For example, it is impossible for all of you to fail TMF1874. So the probability of you failing this course is 0. Betul tak? Now, the second one is the probability of an event that is certain to occur. Yang ni mesti occur. Mesti occur is equal to 1. So, for example, the probability for everyone in this class to score A in TMF1874 is equal to 1. Means that all of you must get A for this course. Betul kan? Alright. Now, and then the third one is the probability any event always range from 0 to 1. From 0 to 1. There's no such thing as if people ask you, what is the probability of this and this? And you said 4.1. Itu salah dah. Probability will not be more than 1. It is in between 0 and 1. Because 0 is impossible. 1 is confirm jadi. The probability is confirmed, certain to occur. Okay, so the probability is in between 0 to 1. So there's no, if you calculate, kalau you kira your probability and then suddenly you get 3.5, then automatically you know already lah. There must be something wrong with your calculations, yeah? Because the probability will be in between 0 to 1. Okay, and then the sum of probabilities of all simple events for an experiment is always equal to 1. Okay, maksud dia when you add every probability for simple event for one experiment, for the similar experiments lah, and when you sum everything, it must be equal to 1. The total must be equal to 1 for one experiment lah. Alright. So the summation for all simple events for an experiment must be equal to 1. Right? Okay, now this is a classical probability. Yang ni I think most of you know already. So the classical probability is applied to compute the probabilities of event for an experiment for which all outcomes are equally likely. Okay. If it's equally likely, for example, for PE, okay, if it's equally likely, we usually, the formula is 1 over the total number of outcomes. Yeah, maksud dia, all the outcomes have an equally likely probability. Okay, so semua ada satu lah. Alright, as for PA, is the probability when you want to calculate the probability for getting A, where the formula will be number of outcomes favorable to A divide with the total number of outcomes for the experiments. Yeah. So we look at this. Okay, this is an example. So find the probability of obtaining a head and the probability of obtaining a tail for one toss of coin. So when you have a coin, there are only two sides, right? So when you toss the coin, it's either head or tail. It's either head or tail, correct? So the outcome is equally likely. So they're sama. The outcome is sama. So the probability for getting head is of course 1 over 2 because the number of outcomes is 2 lah because you have head and tail. So that's why the number of total is 2. So 1 over 2. So the probability for getting head is 0.5 and the probability of getting tail also 0.5. So this is what we call equally likely outcomes. Yeah. Okay. Meanwhile, for this one, okay, find the probability of obtaining an even number in one roll of a die. Okay. So this experiment has total of 6 outcomes, betul? Because a die can have 6 sides. Dia ada 1, 2, 3, 4, 5, 6. So we have 6 outcomes. All these outcomes are equally likely. So let A be an even number only. Even number only is observed on a die. Okay, so even A includes 3 outcomes, kan? Because 3 outcomes, because we want to focus on even number, which is 2, 4, 6. So we have 3 outcomes. Okay, 3 outcomes for even number. So we want to calculate what's the probability for getting even number when we roll a die. So probability of getting even number is equal to how many even number do you have in a die? 3. Divide with the total number of outcomes, which is 6. So you get probability of getting even number in one roll of die is equal to 0.5. Okay. Okay, so far?
Okay, madam.
Yes, madam.
So far, okay.
Okay. So we proceed. So we look at this one. Okay, in a group of 500 women, 120 have played golf at least once. Suppose one of these 500 women is randomly selected. What is the probability that she has played golf at least once? What is the probability that she has played golf at least once? So out of the 500, so we have total number of women is 500. So that's why the total number here is 500. So out of this 500, 120 have played golf at least once. So when you want to calculate the probability of women that has played golf at least once, so you just get 120 over 500 over the total. And you will get 0.24. That will be the probability. Very straightforward. Okay? All right. So now another thing in calculating probability is what we call relative frequency concept of probability. Relative frequency. Okay. When do we need to use this? This approach is used to calculate probabilities when the outcomes of an experiment are not equally likely. Okay, suppose that we want to calculate probability that the next car that comes out from a factory is a lemon. Lemon here is when the car is defective. Okay. Maksud dia, we want to calculate the probability that the car that come out from a factory is defective. Okay, rosak, ada masalah. Okay, is defective. Then the two outcomes, it can be either dia ada defective, it is a lemon, defective, and it is not defective, it is not a lemon. Okay, the two outcome, whether it's defective and not defective, are not equally likely, right? Because we don't know, kita tak tahu kan. Might be if that factory will produce around 500 cars, doesn't mean that 250 is defective, another 250 is not defective, kan? So it's not equally likely, okay? Because if it's equally likely, then macam tadi lah, 250 defective, 250 not defective. So it's not possible that way, okay? So in order for you to calculate the probabilities as such this, you can either use the past data or generate new data by performing experiment at a large number of times. Okay, so this is what we call a relative frequency concept of probability, where you use an approximation to get the probability. Okay, it is not confirmed, dia tak betul-betul cun, but it's approximate to the probability of an event. Okay, you using experiment, for example, using a large data to approximate what is the probability. This is what we call a relative frequency. Yeah. Okay, now. Okay, if an experiment is repeated n times, contoh, this is a contoh of relative frequency. If experiment is repeated n times, so n times experiment, and an event of A observed f times, then according to relative frequency, the probability is f over n. If experiment is n times and then suddenly the event occur f time, so the probability for event A is f over n. Okay. Okay, and please take note that for relative frequency, it is not an exact probabilities. It is just an approximate probabilities. Okay. And law of large numbers. If an experiment is repeated again and again, the probability of an event obtained from the relative frequency approaches to the actual of theoretical probability. It's similar with, I suppose, I hope that you guys have watched last week tutorial, last week lecture, which is chapter 5, because we coming into studying statistics now, chapter 5 until chapter 11. So you should know already. So when for statistics, if you have a large number of data, the result is almost approaching to the actual things. Kalau contoh, if we want to study about students in UNIMAS, for example, and students in UNIMAS is around maybe 20,000 students, yeah, and you want to study all about the characteristic of the students in UNIMAS, maybe the characteristics, maybe how they, whether they prefer, whether out of 20,000 students, how many of them, we want to make a conclusion whether the students prefer online classes or face-to-face classes. Okay, contoh kita nak study 20k students, but we only take around 100 sample. Out from the 20,000, we take around 100 sample. So, is your experiment, is your statistical data approaching to the actual thing? Can you use that data to conclude for every students in UNIMAS? If you just take around 100 out of 2000k? No, right? Because the sample is too small out from the 2000. So makin banyak awak ambil data, makin banyak you get the data from the populations. When we talk about population in UNIMAS, for example, the bigger the sample that you get from the population, the more accurate the result. So similar thing as the probability. That is the law of large numbers. The more things that you get, yes, correct. The closer the sample to the populations, the accuracy increases. Yes, correct. If you can get around 20k all the students, then dia memang accurate lah kan? If you get everyone. But if the sample is too small, then it is not accurate. You cannot conclude for all students. The 100 might be from one program only. So you cannot test the hypothesis. You cannot conclude for everyone in UNIMAS. Macam tu lah. Alright, so that's the law of large numbers. So meaning that for the experiment, if you do it in large numbers, the probability is more accurate. So more approaches to the actual probability. Okay, that's the law of large numbers. All right, so look at this example. 10 of 500 randomly selected cars manufactured at a certain auto factories are found to be defective. Lemons is defective, yeah. Assuming that the lemons are manufactured randomly, what is the probabilities that the next car manufactured at this auto factory is a lemon? Okay. Assuming that lemons are manufactured randomly, what is the probability that the next car tak complete ni. Did they mention? Okay, ni dia tak the data here, the information here is not enough. Assuming the mention randomly, what is the probability the next car mention? All right, so supposedly it mentions that out of the 500, 10 is lemons defective. So when you calculate, you will have to use the previous data, which is the next car of lemon is 10 over 500. 500 is the number of cars manufactured lah. So you calculate, you just get 0.02. That's how you calculate. Adakah dia tulis yang mana? Oh yeah, 10 of the 500. Here. Okay, soalan ni tak salah, saya salah. Alright, mention here 10 of the 500. So to calculate the probability, you have 10 over 500. So you get 0.02. Right? Okay, now subjective probability. Many times we face experiments that neither have equally likely outcome nor can be repeated to generate data. So it's not equally, and you cannot generate the data. So in this case, we cannot compute the probabilities of events using classical probability rule. Also, tak boleh guna relative frequency concept, the one that we discussed earlier. Right? For example, the probability that Ali, who is taking a statistic course, will earn A in this course. Can you, for example, me as a lecturer, yeah, based on my students from previous semester, can I assume that your result, can I assume your result based on the previous semester result? Is it appropriate for me to do that? No, right? Because I cannot use previous data untuk cakap, okay, let's say previous semester student banyak fail, for example. Student banyak fail. There's a lot of students fail, for example. And then now for the next batch is totally different student, new batch of students. But I cannot say that, oh, this semester also they will have a lot of failures, because based on my experience from previous semester, there's a lot of failures. No, right? I cannot do that, because different batch of students consists of different students, consists of semua different lah. The background is different, the level of understanding is different. So I cannot get the probability based on the previous data. Okay. This event is what we call subjective probability. Okay, subjective probability is the probability assigned to an event on subjective judgment, experience, informations, and belief. Okay. Okay, what is the probability that you will get stuck in the next elevator that you ride? Okay, there are two possible outcomes. So it becomes stuck ataupun tak stuck. But of course, we know it is not equally likely. So we cannot use classical approach. And because we don't have historical data on elevator failures, we also cannot use relative frequency approach. Okay, so in this case, experience suggests that probability is quite small. That's the only thing that we know. Probability of getting stuck in the elevator is quite small. So that is the only things that we know. because we don't have much data on it. So we can say that we can estimate that the probability is 0.0001, just to show that how small the probability of getting stuck in elevator can be. Macam tu lah. This is subjective, estimated based on our general knowledge. Based on our general knowledge. Based on my general knowledge for this course, there will not be much failure for TMF1874. So that's based on my experience, based on my knowledge. But I cannot say betul-betul confirm, betul-betul actual probability for this semester. Macam tu lah. Alright. Okay. Are you guys okay so far?
Yes, madam.
Yeah, so far. Okay.
How about, let me ask about chapter 5 last week. You guys okay with chapter 5? Before we continue with this counting rule. Okay. Missing pages for lecture, is it? In the video, is it? Okay, let me go through that one later lah. Okay, whether it's important or not for me to go through. Okay. As for statistics, before we continue, we talk a little bit. As for the statistics, the most important thing is you don't have to worry about the formula, because you know you can refer to the formula anytime, right? During exam, you can refer to the formula. You don't have to worry about the formula. For the statistics, what you need to worry about is you need to really understand which formula for which situations. Because statistics is all about case study. It's all about problems. You want to investigate problems. You want to test the hypothesis, for example. Later on in chapter 7 until chapter 11, it's all about normal distributions. It's all about hypothesis, testing the hypothesis. There will be a lot of formula that will be introduced to you in the next chapter. Yeah. So sometimes it might be confusing for you to mana satu formula nak guna, mana satu formula guna. So the most important thing is you really understand what type of problem will use that formula. Macam tu, alright? So the most important thing later on is you need to understand. You need to really listen to your lecture and then need to understand which kind of problem or which kind of hypothesis that you will need to use different type of formula lah, alright? But basically tak susah sangat lah for the statistics part. Okay, alright, counting rule. Counting rule to find total outcomes. If an experiment consists of 3 steps, if the first step can result in m outcomes, the second step in n outcomes, and the third step in k outcomes, then the total number of outcomes for the experiment is m times n times k. Usually, in this type of questions, in this type of problem, whenever I want to do, I always consider how many outcomes do I have. How many outcomes? If I have 4 outcomes, I put 4 like this. And as the first outcome, how many choices do I have? Contoh ini kan dia cakap M. So I just put M here as the first one. The second one have N outcomes. And the third one has K outcome. And for example, if you have the fourth one, so maybe S here. So the counting rule for the total outcomes will be M times N times K times S. Basically, that's how lah. This is counting rule. So the counting rule can easily be extended to apply to an experiment that has fewer or more than 3 steps. So kalau ada lagi, then teruskanlah darab. Okay, multiply. Okay, for example, suppose we toss a coin 3 times. This one 3 times. We know it's 3 times. And how many total outcomes are possible? So we know that coin dia ada berapa outcome? 2 kan? Coin we have head and tail. Okay, and this one we consider to toss 3 times. So one time kita ada head and tail, so we have 2 choice. And the second one is also 2, and the third one is also 2. So the total outcome of 3 tosses of a coin is 2 times 2 times 2. 2 times 2 times 2 equal to 8. Okay, so that is counting rule. A prospective car buyer can choose between a fixed and variable interest. Okay, he can choose between fixed and variable interest. This is one thing. You can choose between this. And they also can choose a payment period, which is 36, 48, and 60. So how many total outcomes are possible? So first, they have to choose the interest rate, whether they want to choose fixed or variable. So the first one here is the interest rate. So it can be fixed or variable. Okay, are the 2 choices. Okay, that is the first one they need to choose. And the second one they need to choose is a payment period. Okay, so payment period. Why 3 here? Because there are 3 choices. It is 36, 48, and 60. So that's why it's 3. So the total outcome is 2 times 3 equal to 6. Now, conditional probability. Okay, conditional probability is a probability that an event will occur given that another event has already occurred. If A and B are 2 events, then the conditional probability of A given B is written as, this is, when you read this, you read it as the probability of A given that B is already occurred. So given that B is, macam itulah, alright? Probability of A given that B has already occurred. Okay, this is conditional probability. We're going to look at the example after this. Okay, now, suppose that we have 100 employees. So total, we know 100 employees of a companies who ask whether they are in favor or against paying high salaries to CEOs in Malaysian companies. The responses of these 100 employees are shown in the following table. So it is male and female, and in favor, against, so these are the total. So total male is 60, total female is 40, total in favor is 19, total against is 81, and the total number of employees in this experiment is 100. Yeah. Okay. Sometimes in examination, we only give you this. Okay, we only give you this. So this part you need to calculate it on your own lah. So you just extend your table on your own, so that it'll be easier for you to look at the numbers lah. All right. Now compute the conditional probabilities. P, who is probability of in favor given that it is a male, and probability of female given that she is in favor. Okay. So now the probability of the first one, which is in favor given that it is a male. So the formula is the number of males who are in favor over total number of males. So the number of males who are in favor, it is 15, divide with the number of male, total number of male, which is 60. So it is 15 times with, divide with 60. So you get 0.25. Okay. So when you want to calculate probability in favor, given that he is a male, so the formula is number of males who are in favor divide with total number of males. Okay. This info here, this data here, you get it from the table. Okay. And the second one is you want to calculate probability of female given that she is in favor. Given that she is in favor. So the formula will be the number of female in favor divide with the number of employees, the number of employees who are in favor. So the number of female who are in favor is equal to 4 divide with total number of employees who are in favor, which is 19. Total number of in favor, which is 19. So you get 4 over 19. So you have the probability is equal to 0.2105. Okay. Now, mutually exclusive event. So what is mutually exclusive event? Mutually exclusive event is the event that cannot occur together. The event that cannot occur together means that they do not have any common outcomes. They memang stand alone lah, mutually exclusive. Okay, mutually exclusive. So we have, for example, here we have A, even number is 246, B is 135, C is less than 5, is observed, so 1, 2, 3, 4. Okay, so this is the outcome for A, outcome for B, and outcome for C. So the question is, are event A and B mutually exclusive? Okay, tengok A and B dulu, whether it's mutually exclusive. A and B, is there any similar outcomes? No, right? So A and B is mutually exclusive. Are events A and C mutually exclusive? So you look at A and C. Is it mutually exclusive? You have 2 common here, 4 common.
Yes.
So it is not mutually exclusive because 2 and 4 is in both A and C. So A and C are not mutually exclusive. If you draw a Venn diagram like this, you can clearly see A and B is mutually exclusive. See, they stand alone kan? Stand alone, mutually exclusive. Does not intersect with each other. While A and B is not mutually exclusive. Bukan A and B ni, A dengan C. A and C is not mutually exclusive. So you can see it intersect at 2 and 4. So it is not mutually exclusive. Okay? That is the concept of mutually exclusive lah. Okay, now independent versus dependent events. Okay, 2 events are said to be independent if the occurrence of one does not affect the probability of the occurrence of the other. In other words, A and B are independent events if either probability of A given B occurred is actually equal to probability of A. So it means that B does not affect anything on probability of A. So even though B occurred, probability of A given that B occurred is still sama dengan probability of A. Or probability of B given that A occurred is similar, is equal to probability of B. So it means that A does not affect B, B does not affect A. So that is what we call independent. So both A and B are independent because it does not affect the probability of each other. Okay? If the occurrence of one event affects the probability of the occurrence of the other event, maksudnya the 2 events affect each other, we call it dependent events. So dependence event. In that case, it will not be equal to PA. Probability A given B occur is not equal to probability of A. Because when B occurred, there are the changes in the probability of A. Because it affects probability of A. Right? Okay. Now, this is the same table from previously. So we want to see whether event female and in favor independent or not. So we want to see whether both female and in favor, independent or not. Alright, so now event F and A, kita nak tengok sama dia independent or not, right? So if it's independent, it's like this, right? Probability of F given A has occurs have to be equal to probability of F. So we have to calculate probability of F. So probability of favor, so how do you calculate it? Is favor pula, probability of female. So how do you calculate it? You get female 40 over total lah. 40 over total is 0.4. Okay. Now you have to calculate probability of favor female given that it's against. Given that it against, so probability of favor given it is against a female even if it's against is 4, right? Divide with against, right? So it's divided with 19. So you get 0.2105. So you can see that it is not equal. So kalau not equal means that it is not independent, it is dependent. Okay, remember this. It is independent when probability of A given B happen is equal to probability of A. So in this case, when you calculate, it is not equal. So it means that probability events F and A is not independent, it is dependent. Okay. All right. Another example, a box contains a total of 100 CDs that were manufactured on 2 machines. One of them, 60 were manufactured on machine 1. So total is 100 CDs and 60 manufactured in machine 1. Okay, of the total CDs, 15 are defective. Of the 60 CDs manufactured in machine 1, 9 are defective. Let D be the event that randomly selected CD is defective, and A is the event that randomly selected CD was manufactured in machine 1. Event D and A independent. So we have to build a table first so that we can see clearly. So we have 2 machines, right? Machine A and machine B, and we can either be defective and good. So for machine A just now, machine 1 just now, from 60 CDs that manufactured from machine 1, 9 are defective. So 9 are defective. Okay, the total number of manufactured in machine 1 is 60. So we have 60 here. Okay, so 60 and we have 9 here. So the good one is 51 lah. So you just minus 60 over 9. Even though it's not given in the question, you can calculate it on your own. So that's why it's important for you to have a table like this. So it'll be easier for you to see. Okay, and the total number of defective, the total CDs that are defective is 15. So 15, these are the things that we get from the question, 15. So we know that 9 is defective from machine 1, and the rest out of 15, the rest, which is 6, is defective from machine 2. Okay, and the total number of CDs is 100, right? So here is given 60. So machine 2 is 40. Machine 1 is 60. Machine 2 is 40. So now here we already calculate is 51, right? 51. So the rest of it, 40 and 6 we already know. So the rest of it, 40 minus 6 is 34. So the total number of good CDs is 85. Okay. So this one you need to calculate on your own lah. Okay. The one in the yellow box, that one is what you get from the questions. Yeah? You build a table like this for you so that easier for you to look at it. Okay. So now we want to see whether events D and A are independent. So kalau nak independent, we have to show this, right? Probability of D is equal to probability of D given A has occurred. So we want to calculate probability of D. So probability of D, if we want to calculate, is 15 over 100. This is D. This column is D. So 15 over 100. So 0.15. Okay. Now probability for D, given that A has occurred, is equal to 9 over 600. 600 plus 60. Okay, 9 over 60. So you get 0.15. And you can see when you compare, probability of D is equal to probability of D given A has occurred. So kalau sama, we can say that two events, D and A, are independent. Okay, as long as you're able to show this, if it's not equal, then it is dependent. If it's equal, then you can say it is independent. Right? Okay, now complementary event. Okay, complementary event is when we have event A, contoh we have event A, complement of event A is, we denote it as A bar. Okay, this is consists of all outcomes that does not occur in event A. It's complement each other. So in this case, rule of complementary, of course, PA plus with PA bar is equal to 1. Okay. And if you want to calculate PA and you have PA bar, you just minus 1 minus PA bar, then you get A. PA bar is equal to 1 minus probability of A. Okay, this is rule of complementary. Okay, kalau nak cari PA, you just minus 1 minus PA bar. If you want to find complement, every time you want to find complement event for certain things, so you just minus with 1. Okay, minus by 1 lah. Okay, look at this. Okay, a typical question on a test require the test taker to select one of 5 possible choices. Okay, A, B, C, D, or E. Because only one answer is correct, if you make a random guess, your probability of being correct is 1 over 5. Correct? Sebab only out of these 5 choices, only one correct. So the probability of being correct is 1 over 5, which is equal to 0.2. Find the probability of making a random guess and not being correct. Okay. If betul tadi is 1 over 5. So the probability for not being correct is, of course, let's say 1 over 5. So the probability of not getting correct is, of course, 5 over 5. 4 over 5. Because only one correct kan? So the rest are not correct. So which is 4 over 5. So probability for getting not correct answers is 4 over 5, which is 0.8. And if you don't want to calculate like this, you know that this is a complementary event, so you just write 1 minus 0.2, so you get 0.8. So similar, okay, using complementary rules just now. Okay, multiplication rule to find joint probability. Okay, before we continue, you guys okay with previous things?
So far, okay, madam.
Okay, right. So can we continue, or do you want to take a break?
I have no problem. I can continue, but I'll base on the others.
Okay. Continue,
Can.
Right.
Yeah, can.
Now, multiplication rule. Multiplication rule to find joint probability. Okay, the probability of intersection of two events A and B. So in probability, whenever you see N, is actually intersection. So intersection, the symbol for intersection is this. You know, right? If it's N, it's intersection. Okay, and the formula for the intersections, N, A and B. So intersection N tu maksud dia mesti intersection lah, sama lah A and B. Okay. The formula for that is probability of A times with probability of B given A has occurred. Okay, this is the formula. Okay, now given that this table, the following table gives the classification of all employees of a company by gender and college degree. Okay, ni college graduate, ni not a college graduate, male and female. Okay, if one of these employees is selected at random for membership on the employee management committee, what is the probability that this employee is female and college graduate. Is female and college graduate. Yeah? It's female and college graduate. So we want to find this. What is the formula just now when you want to calculate intersection? It's PF times with PG given that it is a female, right? Okay. There are two methods. Okay, look at the first method. This is what we using this formula here, multiplication rule. So look at this. We want to find PFG. So this is the formula. So what you need to do is you need to know what is the probability of a female. So probability of female is, of course, you just take 13. Female ada 13. 13 over 40. Okay, 13 over 40. Probability of graduate female, given that it is a female. So graduate female, it is 4 over female, total number of female, which is 13. So 4 over 30. And you calculate, you get 0.100. This is using the formula. Another method is you get it directly from the table. Sebab kita nak cari probability of female and college graduate, right? So automatically cari terus dapat sini. This is probability of college graduate over total number lah. Over total number of everything, 40. So 4 over 40. So the answer is 0.1. If the question did not mention to use which method, if they did not ask you to use formula for multiplication rules using joint probability, then you can use method 2. If it specifically mentioned that you need to calculate it using joint probability, then you use method 1. Kalau dia tak mention apa-apa, you can just use any method. Okay, as long as you get the answers. Alright, another example. A box consists of 20 DVDs. We have 20 DVDs total. 4 defective. If 2 DVDs are selected at random, okay, without replacement from this box, what is the probability that both are defective? Okay, for example here, we let D1 as the first DVD defective. Kita ambil 2 kali kan? Kita ambil 2 kali tadi. We took 2 DVDs. Okay. The first one is defective. We call it D1. D2, the second event defective. We call it D2. Okay. So we want to calculate what is the probability that both are defective. So probability of D1 and D2 are defective. D1 and D2 are defective. This is what we want to calculate. And based on this, you know the formula is probability of D1 times with probability of D2 given that D1 occurred. Yes, okay, now you need to calculate what is the probability for D1. Probability of D1 is 4 over 20. Okay, 4 over 20. That is probability of D1. Okay. Now, probability of D2 given that D1 has already occurred. So because the selection are made without replacement, so once you take 1 DVDs out without replacement, so the total number of DVDs left is 19 now. Okay, bukan 20 lagi because you already take the first one. And 3 of them are defective. Because, why? Because you already take the first one defective. So only left out of 4, only left with 3. Okay, so the probability of second DVD defective given that the first one defective is equal to 3 over 19. Okay, once you have this and this, you just substitute into the formula. So it becomes 4 over 20 times with 3 over 19. Okay, and you calculate, you get your probability equal to 0.0316. Okay, Okay, now probability of at least one. At least one is equivalent to one or more. At least one is paling kurang satu, paling kurang satu. So paling kurang pun satu ataupun lebih. At least one or more. That is at least one. Okay. So steps in finding probability of at least one. First, use the symbol A to denote the event of getting at least one. And then let A bar represent event getting none of the item considered. So at least one, PA is at least one, right? And the complement of at least one paling banyak pun satu, paling sikit pun satu. The complement of paling sikit pun satu is A bar, which is none, kosong, right? That is the complement of at least one. P bar, we call it P bar, means that none, getting none, okay? Calculate the probability that none of the outcome result in the event being considered. Okay, we calculate P A bar, which is none. And in order for you to calculate at least one, of course, using complementary, of course, it is 1 minus P A bar because of complementary, right? 1 minus probability of getting none, then you will get probability of at least one. Okay, so PA is equal to 1 minus PA bar. Probability of at least one is equal to 1 minus probability of getting none. Okay, so this is how you calculate probability of at least one lah. Okay, now look at this example. Find the probability of a couple having at least one girl among 3 children. Okay, out of 3, at least one girl. Assume the boys and girls are equally likely. So means that equally likely is getting, probability of getting girls is 1/2. Probability of getting boys is also 1/2, equally likely. And the gender of child is independent of any other child. Okay, that is our assumption. So now, probability of A is at least one. Yeah, this is probability of A, at least one. A, yeah, A. Then, of course, the complementary A bar is not getting at least girl. Means that you get boy, semua boy. None of them are girls. That is A bar, the complementary of A. So means that out of the 3 children, you get boy, boy, boy. Okay. So the probability of getting all boys is, of course, 1/2 times with 1/2, and 1/2 equal to 1/8. Okay, equal to 1/8. Why 1/2? Because mentioned here, we assume that the probability of getting boys is equally likely. That's why it's 1/2. So the probability, we want to find the probability of having at least one girl. So probability of having only one girl is equal to 1 minus all boys tadi. No girls. 1 minus all boys, probability of all boys. So you will get the probability of at least one girl. So this is the probability of at least one girl. Okay? Okay. Now, calculating conditional probability. If A and B are 2 events, then this is one of the formula. Then probability of B given A has occurred is equal to probability of A and B divided with probability A. This is actually the same formula with the previous one. It's just that yang tadi kita tulis macam ni kan. We manipulate the same formula actually. Yang tadi macam ni. A and B is equal to PA times with PBA. It comes from the same the same formula. It's just that we manipulate it so that we can calculate the conditional probability using the same formula. Okay. So look at the example. The probability that a randomly selected student from a college is a senior is a senior is 0.2. Okay, and the joint probability, the student is computer science and senior is 0.2. So the joint probability is 0.2. Probability of getting a senior is 0.2. Find the conditional probability that the student selected at random is computer science major. Okay, computer science major, given that the student is senior. A and B, they use A and B. All right, so we have, okay, given that the senior, we use A. So given that the senior, this one we get it from the example, from the question, we get it 0.2. And the joint probability A and B is 0.2. Dia cakap kat sini, joint probability of computer science and senior is 0.03. So the joint probability is 0.03. Okay, so you have all the data here. Now you want to calculate apa tadi? We want to calculate the conditional probability given that probability of computer science major given that the student is a senior. So we want to calculate the student computer science major given that the student is a senior. So we just use the formula and substitute all the values, the joint probability and PA, and you will get the conditional probability is equal to 0.15. Okay, you just substitute into the get the information from the example, from the questions, and you just substitute into the conditional probability formula. Okay. All right. Multiplication rule to calculate probability of independent events. Yang tadi dependence kan, because we use conditional. If you notice here, we use conditional probability. So when you use conditional probability, this is dependent event because this is dependent. B depends on A depends on B. In this case, independent events, the probability of intersection of two independent events A and B is equal to P A and B. Probability of A and B is equal to probability of A times with probability of B. Okay, this is for independent event. Okay, now, for example, an office building has 2 fire detectors. The probability is 0.02 that any fire detector of this type will fail to go off during a fire. Find the probability that both of these fire detector will fail to go off in a case of a fire. So you know that probability 0.02, it will fail to go off during a fire for 2 fire detectors. So of course, both 2 fire detectors, the probability is independent, right? Doesn't mean that one fire detector's defect, another one also defect. Tak semestinya kan? So it is independent event. So the probability for A and B to fail to go off during a fire is equal to probability of A times with probability of B. So in this case, it is 0.02 times with 0.02. So you will get 0.004. So this is for independent lah. Okay, the 2 fire detectors are independent because whether or not one fire detector goes off during a fire has no effect on the second fire detector. So both are independent. So we use this formula where P, probability of A and B is equal to probability of A times with B. Okay. What about joint probability for mutually exclusive event? Kalau dia mutually exclusive event, so does the joint probability exist? So the probability for mutually exclusive event for probability A and B is equal to 0. Why? Because when you draw a Venn diagram for mutually exclusive, this is A, this is B. When you draw a mutually exclusive event, there is no intersection, means that this one does not exist, N. N is intersection, N is macam ni, this is N, intersection, yeah. So for joint probability for mutually exclusive, it is equal to 0. Okay, consider this example. Consider the following two events for an application filed by a person to obtain a car loan. So A is event that loan application is approved. R is event that loan application is rejected. So what is the joint probability for A and R? So these two events is clearly mutually exclusive because it can either be hold on. Okay. So it can either be whether the application approved or rejected. It's mutually exclusive. It cannot be both, right? So the joint probability for this A, since it's mutually A and R, since it's mutually exclusive, so the probability is 0 lah. Okay. Okay, now addition rules. Okay, addition rules, the probability of union. Tadi intersections, yeah, intersection where A and B, the intersection. This symbol, this is intersection. So now the probability of union of two events, A and B, this is OR, we use OR. For union, we use OR, and the symbol is like this. This is all, okay, union. And I think you learned this in discrete mathematics previous semester. It's almost similar like this, but we talk about sets, right? Before this.
Yes.
Yeah, so for probability for A or B is equal to PA, probability of A plus probability of B minus intersections, minus P, A, and B. And we get the union for A and B, okay? So you look at the example here. A university president proposed that all students must take a course in ethics as a requirement for graduations. 300 faculty members and students from this university were asked about their opinions on this issue. So total is 300. 300 the combination of faculty members and students. The following table gives two-way classifications of the responses of these faculty members and students. It can be favorable, opposed, and neutral. Find the probability that one person selected at random from these 300 persons is a faculty member or in favor of this proposal. It's a faculty member or in favor of this proposal. So for example, let me say that A is a faculty member, event B is in favor. Okay, so probability of faculty member is, look at the table, faculty member is 70 divided with the total 300. 70, 300, so this is the probability. And the probability of in favor, so in favor, the total is 135 divided with 300. So you get 0.450. Okay, so now using the since we know we want to calculate the union, right? So union, so you need PA, this one already, you calculate this already. You need PB, you already calculate this. Now you need the intersections, P and B. So how do you get P and B? Is using the formula previously, the conditional joint probability. So PA times with probability of B given that A has occurred. So probability of A, you ambil je dari atas ni, probability of A, this one. So you just substitute here. And probability of B, where it is in favor, given that it is a faculty members. So in favor faculty members is 45. So 45 over faculty members lah, 70. So 45 over 70. So you calculate. So you get everything. 1, 2, 3. You get it already. And you get the formula for the union, for the addition. You get the formula for addition. So you just substitute into this. And you will get 0.233 plus 0.450 minus 0.150. So you get the union for A and B is 0.5333. Okay. Or you can use the second method where you can get directly from the table. So the total numbers of persons who are either faculty members or in favor in this proposal is faculty members in favor in this proposal is 45 plus 15 plus 10 plus 90. 45 plus 15 plus 10 plus 90 equal to 160. Hence, the probability for one person selected a random of this 300 is 160. 160 divide with total of number of everything lah, 300. So you get 533, which is also the same with the one that where you use the addition rule just now. Okay, so if just like before, if the question did not mention to use which formula, which method, then you can choose whatever methods you want as long as it is correct lah, right? So it depends on you. If it did mention, you kena guna conditional join probability and addition rule, then you follow whatever it is requested lah. Okay. Now another example. In a group of 2,500 persons, 1,400 are female. Total 2,400. Female is 1,400. 600 are vegetarian. 400 are female and vegetarian. Okay, so this is a joint probability. Is joint probability of female and vegetarian is 400. So what is the probability that a randomly selected person from this group is male or vegetarian? So we have F as a female, even F is female, M is male, B is vegetarian, and N is non-vegetarian. Okay, so this yellow box here is the one that you can get from the questions. You fill in the yellow one first. So you know that how many female is vegetarian is 400, right? 400. So you just write 400 first. And then what else? You know that there is 1,400 females. So you know the total of number of female is 1,400. And then you also know that 600 are vegetarian. So you know the total number of vegetarian is 600. And you know that the total number of everyone is 2,500. So 2,500. So anything else that is not given to you, you can calculate it yourself. Macam contoh, like this one is 400, is you know 400 and 600 already, right? How to get this is 600 minus 400, you get 200. This one, you know 400 and 1,004 already. How do you get this one? Is 1,400 minus 400, you get 1,000. And you know 140 and 500 already. So how do you get this? Is tolak je lah. Then you get 1,100. Okay, and then this one also similar. Dah dapat ini, dah tahu ini, then you can get this. And you can sum everything. You get one. For non-vegetarian, you have total number of 1,900. Okay, so now we want to find apa yang dia suruh kita cari. It is probability that a person from this group is a male or vegetarian. Male or vegetarian. Male or vegetarian. So you look at this and you can write down the formula. It is probability of male plus probability of vegetarian minus probability of getting male and vegetarian. So male berapa? Mana satu male? So 1,100 divide with total lah 2,500. For vegetarian pula, you have how many? 600 vegetarian and out from the total 200 and 500. This is probability for vegetarian. How about for male and vegetarian? So male and vegetarian is here, right? Male and vegetarian. So 200 over total 2,500. So you calculate and you get 0.6. Is when you create this table lah. Tapi so now macam biasa we have a second method. So where you get the directly from the table. So you get 200 plus 900 plus 400 equal to 1500. So when you want to calculate the probability, then you just 1500 divide with total number of semua, and you get 0.6. Is it the same? It's the same. Okay, you have one method and second method. Okay, now addition rule for you mutually exclusive event. Addition rule for mutually exclusive event. You still remember mutually exclusive event looks like this. Okay. So the union of two mutually exclusive event is of course PA plus PB. PA plus PB. Because there is no intersection, you don't have to minus intersection because it does not exist. So probability of union of A and B is equal to PA plus PB for mutually exclusive events. Okay, look at this example. A university president, I think this is similar with the previous table. So we look at the question. What is the probability that a randomly selected person from these 300 member students are in favor or neutral? We want to find the probability of in favor and neutral. In favor and neutral. You can see that both are actually mutually exclusive, right? Because it does not intersect with each other. Favor lain, neutral lain. So it does not, dia tak macam student and favor, the intersection. So what you need to do is you just need to plus the probability. So probability of in favor or neutral, and what you need to do is tambah probability of in favor and probability of neutral. So in favor is 135 over 300 and neutral is 40 over 300. 135 over 300 and 40 over 300. And you get 0.5833. And this is an example of mutually exclusive event lah. Okay. Dia tak ada intersection, so you just plus the event itself. Okay. This is the last section where we want to go into Bayes' theorem. Okay, Bayes' theorem. In Bayes' theorem, there are prior probability and there are also posterior probability. Prior probability is an initial probability value originally obtained before any additional information is obtained. Maksudnya initial probability. The original initial probability, that is prior probability. The posterior probability is the probability value that has been revised using additional information that is later obtained. Okay, prior is the initial probability, posterior is the probability value that has been revised after you gain additional information. That is posterior probability. Okay. Now you look at the example here. The Gallup organization randomly select an adult American for a survey about credit card usage. Use subjective probabilities to estimate the following. You still remember what is subjective probabilities? Where the probabilities is, we don't know the actual probabilities, we just based on the probabilities is we use based on belief, based on what we know, based on itulah. We don't know, it's not an actual probabilities, yeah, it is a subjective probabilities. So what is the probability that the selected subject is male? Number two, after selecting a subject, it is later learned, okay, it is later learned that this person was smoking cigar during interview. What is the probability that selected subject is a male? Which of the preceding two results is a prior probability and which are posterior? Okay, prior probability, what is it just now? It is initial probability, which is the number one. Number one is before you know you have any information, what is the probability that the subject is male? That is the initial probability. You don't have any other information. But number two, after you selecting a subject, it is later learned that the person was smoking cigar during the interview. Ini ada new informations. So this is posterior probability. You see the difference? Prior is when the initial probability. Posterior is the probability when you have additional informations. Macam contoh ini, there's the initial, additional informations that the person was smoking cigar during the interview. So what is the probability that the selected subject is a male? So number 1 is prior probability, number 2 is posterior probability. Okay, for number 1, first that we have, kita nak tahu probability for getting males kan? So at first that probability for getting males is, of course, is 0.5 because we only know it's between male and female, right? So probability of first, our initial probability, our prior probability is 0.5 because it either can be it either can be female or male. Yeah. Okay. And number 2, okay. Although some women smoke cigars, the vast majority of cigar smokers are male. So that is the additional information that we have. Dia bagi tahu kita during the interview that person smokes cigars. So automatically, 85%. This is based on subjective probabilities, yeah. Subjective probabilities. Belief kita. A reasonable guess is that 85% of cigar smokers are males. Okay, this is what we assume based on our belief. Okay, we estimate that the probability of this person being male is 0.85 now. Because why? Because we know that that person smokes cigars. So the probability, the posterior probability now become increasing to 0.85. Sebab ada additional, because we have additional informations that that person smokes cigars during interview. So, mungkin lelaki lah ni kan? Because the higher, mungkin lelaki lah. Because why? Because from our belief, from our background, most of the cigar smokers is males. Yeah. So that's why the posterior probability increasing. So in part 3 just now, we need to say which one is prior, which one is posterior. So the value of 0.5, that is the initial probability, that is the prior probability. Okay, this is the prior probability. And then once we have additional informations that the subject was smoking cigars, now this will become 0.85 will become the posterior probability. Okay, maksud dia yang first tadi initial, and after we get some more information, that will become our probability change, that will become our posterior probability. Okay, Amirul, number 1 assuming, what do you mean?
Tu soalan untuk tadi dah lepas.
Dah tadi, tak ada. Okay.
Dah.
Alright. Okay. That is prior and posterior. That is prior and posterior. Now, the probability of event A given that B has subsequently occurred is given by this formula here. This is Bayes' theorem. Based on the prior probability and the posterior probability, we use this Bayes' theorem here, the formula for probability of A given that event B has occurred. Okay. For example, okay, contoh, in Orange County, 51% of adults are male. One adult is randomly selected for a survey involving credit card usage. Okay, find the prior probability that the selected person is male, the first question. And the second one, it is later learned, ni posterior ni, it is later learned because you have additional information. It is later learned that the selected survey subject was smoking a cigar. Also, 9.5% of males smoke cigars, whereas 1.7% of females smoke cigars. Okay, ni based on the data that they have lah, based on the this is not actual, this is based on apa sahaja data yang we have, they have lah. Use this additional information to find the probability that the selected subject is male. Okay, M is male, M bar is female. Okay, C is cigar smoker, C bar is not a cigar smoker. Okay. A, from this is prior probability. From the given information, 51% of adults are males. So our prior probability is 0.51. Okay, 0.51. So from these informations, our probability for male is 0.51. So the complement of, so M bar is of course 0.49. How do you get this? Tolak satu je. 1 minus 0.51, you get 0.49. Now, probability for getting cigar smoker, given that it is a male, is given in the second text here, where it is 9.5%, so 0.095. And probability of cigar smoker, given that this is new information given to you, given that it is not male, means female lah kan, kalau tak male, female lah, is 1.7%. So means that the probability is 0.017. So you have these four information here. So what you do is you just substitute. Ini you dah ada. This one also you have this in posterior probability. And this one also you have. So you just substitute. This one also you have. This one also from the posterior probability. So you just substitute the prior and the posterior probability into the formula, and you will get, and you calculate lah, and you will get approximately the probability for getting male and cigar smoker is, given that it is cigar smoker, is 0.853. Macam tu. Okay. This is how you use the formula for Bayes theorem. Okay, now intuitive Bayes theorem. So tadi we use directly from the probability, you know, we use directly. Now in intuitive Bayes theorem is where we assume, we give numbers to it. Kita guna numbers. For example, in this case, we assume that the population is 100,000. So kita letak out siap-siap dah number, total 1,000. So means that our male is is apa tadi? Is 0. How much we calculate? So we calculate everything based on this 100,000. Okay, kita kira everything from this 100,000. We know that male is 51%, right? So out from 100,000 is 51,000 for male. For female is 49,000. Okay, and you fill in all the data here based on our assumption of 100,000. This is intuitive Bayes theorem lah. You assume numbers. You assume numbers of populations in order for you to calculate. Okay. Now, probability of getting male, given that the subject is a cigar smoker, okay, is, macam mana nak cari, is from here, male provided is cigar is 4,845 divide with the number of cigar smoker lah, 5,678. So when you calculate, you get approximately 0.853, which is, when you compare with the one you calculate using the probability, you get the same, 0.853. So the difference is that this one, you use only probability to calculate, okay? This is Bayes theorem. This is intuitive Bayes theorem, where you need to assume, give numbers to the number of population. Give numbers, create a table, and calculate macam ini. This is intuitive Bayes theorem, where you assume values for the population. Faham? So in a case where soalan tu cakap use intuitive Bayes theorem, then you know what to do. You assume values, give values for the populations, and create a table like this and calculate. If it only mention Bayes theorem without intuitive Bayes theorem, then you can directly use probability like this lah. Okay. Okay. The preceding formulas for Bayes theorem and the preceding example to its categories even male, but the formula is into more than two categories. We're dealing with two event. We must be disjoint. Okay, this one just a general thing lah. Okay. Look at this example. An aircraft emergency locator, ELT, is a device designed to transmit a signal in the case of a crash. And Altigaj manufacturing companies makes 80% of ELTs. Brian Company makes 15% of ELTs. Altigaj make 80%, Brian make 15%, Chate makes 5%. ELT made by Altigaj have 4%, Altigaj 4% defects. Brian have 6% defects. Chate have 9% rate of defects. If ELT is randomly selected from the general population of ELTs, find the probability that it was made from Altigaj manufacturing. So this is the first question. The second question is, if a randomly selected ELT is then tested and is found to be defective, find the probability that it was made by Altigaj manufacturing companies. Okay. Now we have to name the event first. Okay, A is manufactured by Altigaj, B is manufactured by Brian, C is manufactured by Charte, and D is defective. ELT manufactured is defective, and D bar is not defective. So we have A, B, C, D, and D bar. Okay, so probability for getting A manufactured by Altigaj, right? Question 1 is, what is the probability of ELT made by Altigaj? So which is, we have here 80%. This is our prior probability, 80%. So our prior probability is 80, 0.8, right? And then for question 2, from the given information, okay, from the given informations, we know that, okay, PA is 0.8, PB, this one also we get it from, B is 15%, C is 5%, okay? C is 5%, B is 0.15, 0.15. And then probability of defective, given that it is A, berapa tadi dia cakap? If made by Altigaj, 4%. If made by Brian, 6%. If made by Chate, 9% percentage of defect. So 0.04, 0.006, and 0.09. Okay, and then what do you do next? You just substitute into the Bayes theorem. So you substitute some more value in the Bayes theorem and you have 0.703. This one you rounded already lah. So you can round it around 3 decimal place for probability. 3 decimal place, approximate to 3 decimal place lah. Okay. Okay, another solution, which is this one, where we use intuitive Bayes theorem tadi kan, where we assume, we give values to the populations. So in this case, we give values total 10,000. Why we give 10,000, 100,000? Why? Because it will be easier for us to calculate untuk 10,000, 100,000. It's easier for us to calculate that way. So in this case, we assume that we have 10,000 manufactured. Okay. So based on our percentages now, so from the 10,000, 8,000 is Altigaj, 1,005 is Brian, and Chate is 500. Okay, and then you fill in all this information. Okay, based on your based on the percentage given in the questions lah. Okay. Okay, now you want to find what is the probability of manufactured by Altigaj, given that it is defective. So it is 320 divided with defective, 455. So the probability is 0.703, which is similar when you use probability, directly use probability. So this is intuitive, where you assume values to your populations. Yeah. Okay. Now I think this is the last example. This is the last example. So this is a drug test result. Okay, this is drug test result. So we have drug user, not drug user, positive test and negative test. We have this given to you. So A, if one of the 99 test subject is randomly selected, what is the probability of getting a subject who is a drug user? That is A. B, a test subject is randomly selected and is given a pregnancy test. What is the probability of getting a subject who is a drug user given that the test result is positive? Okay. So A, first we have to label lah. What is D, what is D bar. So D is drug user, D bar is not a drug user, P is a positive result, P bar is a negative result. Okay, so probability for D is, this is, it's better for you to write total here lah. Okay, so it'll be easier for you to see. So here is 85, here is 14. So 95. 95 pula. 99. Total is 99, right? Here is 16 and here is 83. So probability of PD is now, D is what is now? Drug user is 85 over 99. So 85 over 99 is probability of drug user. So from the given information, you have probability of drug user is 0.859. Okay. And probability of positive given that it's drug user. Positive given that it is drug user. So 80 divided with 85. 80 divided with 85, you get 0.951. Probability of not a drug user is 14 over 99, or you can just minus from here. So you get 0.141. Probability of positive and not drug user. Probability of positive and not drug user is 3 over 83. Okay. Probability of positive, given that it's not a drug user, 3 over, 3 over 14. 3 over 14. So 3 over 14, so you get 0.214. So once you have every information, so you just substitute into the formula and you calculate lah, and you round up, we round it, and you get 0.964. Okay. Now we look into when we want to use intuitive Bayes theorem. In this case, you already have the table, right? So you just need to construct macam saya buat tadi lah, total je. And probability for drug users, given that the test is positive, is probability of drug users, given that it is positive. Automatically dapat 80 over 83. So you get 0.94, which is the same with the one you calculate from the first solution. This is intuitive. This is intuitive Bayes theorem. This is the normal Bayes theorem. Okay. Right. That's it for today's lecture. Any questions? You guys okay so far? Okay.
So far, okay, madam.
Right.
So far, no problem.
Belajar maths petang-petang tak best sangat kan? Usually we learn maths in the morning.
Exactly.
Alright. So if any nothing else, then we stop here. Oh, I don't have QR code for today because we have some masalah sikit with the QR code. I don't know, maybe something wrong with the system today. Okay, so we can't have the attendance for today. So if nothing else, if you don't have any questions, we will stop here. So I'll see you next week on Friday. Yeah. Okay, that's
All right,
it.
madam.
Okay, madam. Thank you.
Bye.
Bye.
Thank you, madam.
And
Thank you, madam.